Okay, so here we have the function that's equal to -2 between 0 and 3, and then e to the t minus 3 when t is greater than or equal to 3. Okay, I'd like you to take a moment, try and write this down, and then we can come back and look at it. Okay, so we're going to look at both sort of styles. So style 1 is looking at the change in the functions. Okay, so here we have f of t. Starts out at the value -2. And then what we do is we look at the change from, we do our new rule minus our old rule. And this needs to happen at time 3. Okay, so we multiply by u3 of t. Okay, rewriting this a little bit gives us -2 plus e to the t minus 3 plus 2 times u3 of t. Okay, so style 2 is with pulses. Here, f of t is equal to -2, and we want to keep this on until we get to time 3, in which case we're going to turn it off. So we're going to say -2, or +2 rather, u3 of t. And now we want to turn on e to the t minus 3. So we're going to multiply e to the t minus 3 times u3 of t. Okay. All right, we can see this is the same expression. Great, let's try out the next one. So here, this function is equal to 0 when t is less than 3, and t minus 3 to the 5th when t is greater than or equal to 3. Okay, so we're going to write f of t is equal to u3 of t times, times t minus 3 to the 5th. Great. Okay. Great. And so next up, we're going to take a look at a couple of examples where we have a piecewise function written in this notation, and just to feel good about writing this into our regular notation, we're going to do a couple of examples. Okay. So we're going to have kind of a number of different t regions that we're considering. So if we look at this first example, g of t is 2u2 of t minus u4 of t plus 3u7 of t. We can think of having t less than 2. Yeah, let's write this all out. G of t is going to be equal to, so we're going to first think of t less than 2. I'm going to be pulling these numbers from where these steps happen, and t between 2 and 4. And I'm just putting them in the order from smallest step to largest step. They were given to us in this order. And then t between 4 and 7. And then t bigger than 7. Okay, so we're going to have 4 rules going on. Okay. All right, when t is less than 2, then we are going to think of u2 of t being off, u4 of t being off, and u7 of t being off. Okay, and so by off, what I mean is that all of them give us 0. Okay. Next up, we're going to be looking at when t is between 2 and 4. Okay, t is going to be between 2 and 4. And just because I think this light bulb analogy is helpful to think about, I'm just going to light up the function that we have on right now. Okay, so the only one that's on is u2 of t. That's going to give us a value of 1. And then the others are going to give us values of 0. Because the input that we're giving is going to be less than these light switch times at 4 and at 7. Alrighty. So next up, let's look at t values between 4 and 7. Okay, so now when t values are bigger than 4, that means that u4 of t is going to be on as well. Okay. So the on functions are going to have values of 1. So we have 2 times 1 minus 1, and then plus 3 times 0. And finally, when we look at t values that are bigger than 7, now our t value is bigger than the light switch time for each one of these functions. So all 3 functions are giving outputs of 1. And so this gives us 2 times 1 minus 1 plus 3 times 1. Okay, and then so putting this all together, just evaluating this, we get values of 0 when t is less than 2. We get a value of 2 when t is between 2 and 4. We get a value of 1 when 4 is less than t is less than 7. And we get a value of 2 minus 1 plus 3. So of 4 when 7, oh, sorry, when t is bigger than 7. All right, cool. Let's try out another. So here we have the function that is equal to cosine of t times u pi of t for t greater than or equal to 0. Okay, so g of t here has just one switch going on. We're going to be equal to cosine of t times 0 when t is less than pi. And we're going to be equal to cosine of t times 1 when t is greater than pi. And so this is equal to 0 and cosine of t when t is less than pi, and then when t is bigger than pi. Great. Okay. So next up, we're going to take this initial value problem. I want you to take just a minute, try and rewrite it. What I'd like you to do is to rewrite the right-hand side here, f of t, which is this piecewise function that's equal to t when t is less than 1 and 0 when t is greater than or equal to 1. I want you to try and write it with this step function notation. And that is it. Just recopy the DE with the right-hand side written in as, oh,